Hi, I am Atanu. In this tutorial video, you learn the prime numbers and divisibility rules. Also, you learn how to identify given number as a prime number under the number system chapter. Here you develop the skill of arithmetic ability of quantitative aptitudes. So let's learn this concept. First, we learn what is prime number. Prime number are those positive integer that has exactly two factors, that is number itself and 1. So let's take one example, 13. Why it is prime number? Because 13 has only two factors, that is 1 and 13. Not any other numbers can divide this 13. And what is composite number? The numbers that has more than two factors. Example 12. 12 you can divide by 1, 2, 3, 4, 6 and 12. So there are more factor other than 1 and number itself. That is 2, 3, 4, 6 also are the factors of 12. Next we learn the different type of the prime numbers. One is co-prime number. It is the pair of the numbers that have only one common factors, that is 1. Let's take one example, 5 and 7. So here the common factor is 1. Although 5 and 7 are prime number, but if we take another example, that is 12 and 13, this is also a co-prime number. Why? Because only there is a common factor 1. Although 12 is a composite number and 13 is a prime number, so it is not necessary that co-prime numbers is considered for the two prime numbers. It could be two prime numbers or any pairs of the composite numbers or prime numbers also. Clear? Next we learn the twin prime numbers. These are the pair of numbers having the difference 2, and also this number should be prime numbers. Let's take one example, 5 and 7. This pair of the number is prime number and difference is 7 minus 5 equal to 2. So we can say that 5 and 7 are twin prime number. Next we learn the prime triplets. Prime triplets are three prime numbers, which we can write as p plus 2 and p plus 6 format, or p plus 4 and p plus 6 format. Let's take one example. Suppose p is equal to 5. So 5 is a prime number, and next number will be p plus 2, 7, and p plus 6 is 11. So 5, 7, 11 are the prime triplets, because these three numbers are prime numbers. Also it's follow this format. And if we consider p is equal to 7, and if we consider p plus 4, it will be 11, and p plus 6, so it will be 13. So 7, 11, 13 also the prime triplets, because these three prime numbers follow the p plus 4 and p plus 6 format. Clear? Next we learn and also remember how many prime numbers are there in between 1 to 100. So in the form 1 to 9, there are prime number 2, 3, 5 and 7. Next, in between 10 to 19, 11, 13, 17 and 19. Up to this it is very easy to remember, but next you just follow my rules so that you can easily remember this. From 20 to 29, you have to check only the unit digits, either 1, 3, 7 or 9. Okay. Why? Because if the unit digit is, later we learn the all these things, the divisibility rules. If the unit digits is of any two digit number is 2, 4, 6, 8 and also 0, these are the even number, so divisible by 2. So this will be composite number, not prime number. So only we have to check 1379 as a unit digit number. So let's take one example. In between 20 to 29, the number will be 21. First consider 21, but 21 is divisible by 3. So 21 is not possible. So the next will be 23, but 23 is not divisible by 3, 5, 7 or any other number. So next will be 27, but 27 divisible by 3 because sum is divisible by 3. Check it. 27, if we add 2 plus 7, 0, 9, so it is divisible by 3. So 27 is not possible, it is not the prime number. And next is 29, correct. In between 30 to 39, first consider 31, we follow that same rule, and 37. And in between 40 to 49, there are 41, 43, 47, okay, and 49, it is not the prime number because it is divisible by 7. Next is 50. In between 50 to 59, it will be 53 because 51 is divisible by 3. 53, then 57 also divisible by 3, and it will be 59. And in between 60 to 69, the number is 61 because it is not divisible by either 3, 7, 5 or any other number. And next is 67. Next is 70. In between 70 to 79, it is 71 and 73 and 79. And in between 80 to 89, the prime numbers are 83 because 81 is divisible by 3, and 87 also divisible by 3, so it will be 89. And between 90 to 100, there is only one prime number, that is 97. Now follow the similarities, except 40 series and this and 70 series, there are 3 prime numbers, and from 20 to 80 series, there are 2 prime numbers each. Only except the 90 and in between the 90 to 100, there is only 1, and from this 1 to 20, actually it is easy to remember. These are the prime number. Why we should remember most of this prime number? Because it will be very easy to simplify a complex calculation. Next we learn the divisibility rules of mostly prime numbers and few composite numbers. First we learn the divisibility rule of 2. If the unit digit is even number like 0, 2, 4, 6, 8, let's take one example, is 2, 4, 7, 0. So without divide this entire number by 2, by looking this unit digit number, you can say that this is divisible by 2 because 0 is the even number. And another example, 758. Why this is divisible by 2? Because unit digits has 8, which is even number. Next we learn the divisibility rule of 3. If the sum of the numbers or sum of the digits is divisible by 3, then we can say it is divisible by 3. Let's take one example, 327. How we can know that this 327 is divisible by 3 or not? You have to add 3, 2 and 7, that is 12. And now 12 is divisible by 3. So you can say that 327 is divisible by 3. And next is 4. If the last two digits of the given number is divisible by 4, then you can say the number is divisible by 4. Let's take one example, 2816. Since this last two digit is 16 and 16 is divisible by 4, so you can say that 2816 entire number is divisible by 4. Next we learn divisible by 5. If the last digits or the unit digit is 0 or 5, then we can say the number is divisible by 5. Let's take one example, that is 750 and 285. Both these numbers are divisible by 5 because the unit digits as 0 or 5. Next we learn divisible by 6. For this we have to consider or prime factorize 6 into 2 co-prime number. So you must remember this should be co-prime number. And now we have, if the given number is divisible by 2 and 3 both, then we can say the number is divisible by 6. And we already learned that the condition to become the number divisible by 2 and 3, so we separately we check it, then we can say that the number is divisible by 6. So let's take one example, 4734. Why it is divisible by both 2 and 3? Because here is 4, it is even number, so divisible by 2, and if we add the all numbers, 4 plus 7 plus 3 plus 4, we get 18. So 18 is divisible by 3. So this number is both divisible by 2 and 3. So we can say that 4734 is divisible by 6. Clear? Now we learn the divisibility rule of 7. For this, first we take one example, 623. What we have to do? You have to multiply this unit digit number with 2 and deduct from the rest of this number. So it will be 6 and it will be 56, and 56 is divisible by 7. So we can say that 623 is divisible by 7. And another method is, if the number is very large, for example 196875, so we make the group of 3 from the right side and deduct it. So 875 minus 196, it will be 796. So 679. Now you apply the first rule. What is the first rule? You have to multiply it into 2 and deduct it 7. So 49 is actually multiple of 7. So you can say that 196875, this large number, is divisible by 7 by applying this 2 method. And one thing you must remember, you have to apply this concept, means the unit digit multiply 2 till you get 2 digit number. What that mean? So let's take one example. 1792. We have to check whether this number is divisible by 7 or not. So we have to multiply 2 into 2 and it will be 4, then deduct and we get 5 and 7 1. Again we multiply 2, it will be 10 and you deduct is 7. Now 7 is multiple of 7, obvious, so 7 into 1. So we can say that 1792 is divisible by 7. This is the method 1 and this is the method 2. Clear? Next we learn the divisibility of 8. If the last 3 digit is divisible by 8, then we can say the given number is divisible by 8. Let's take one example, that is 78432. So we have to consider 432 and check it whether it is divisible by 8 or not. So it is divisible. Clear? So we can say that 78432 is divisible by 8. Next we learn the divisibility of 9. If the sum of the all digits is divisible by 9, you can say it is divisible by 9. So it is same rule as divisibility of 3. Okay, let's take one example, that is 4068. If we add all digits, we get 18. So 18 is divisible by 9. So you can say that this 4068 number is divisible by 9. Next, divisibility rule of 10. If the last digit is 0, then we can say the number is divisible by 10. Example 2580, 390. These all are the divisible by 10. Okay. Next is divisibility rule of 11. If the even position sum and odd position sum difference is divisible by 11 or 0, then we can say the number is divisible by 11. Let's take one example, 9856. So even position digits are 2, this is second position, and fourth position, means 1 2 3 4. So we have to add 9 plus 5, that is 14, and odd position digit sum is 6 plus 8, that is 14, and the difference is either 0 or multiple of 11s. So let's take another example, 64823. What we have to do? The 1 2 3 4 5. So we have to add the even position 2 plus 4, and next odd position is 3 plus 8 plus 6, 17, and this is 6. And if we deduct 17 minus 6, it will be 11. So we can say that this number is divisible by 11. Next we learn the divisibility rule of 12. Again prime factorize into the co-prime number 12 can write as 3 and 4. So you have to check if the number is divisible by 3 and 4. Then you can say the number is divisible by 12. You can verify. Let's take by this example 10752. This number is divisible by both 3 and 4. Next is 13. For divisibility rule of 13, let's take one example, that is 2795. What you have to do? We have to multiply last digit into 4. This 20. Then you add the rest of the number. This is the rest of the numbers. So it will be 9, 9 and 2. Again multiply 4 and 36, and it will be 5, 6. 5 into 13. This 65 is multiple of 13. So you can say that this given number is divisible by 13. And another method is like the 7 method, divisibility of 7 method. Suppose one large number given 33397, we have to make 3 group from the right side, 3 digit group, and then deduct it. 397 minus 33, so it will be 4, 6 and 3. Then you can apply the first method, that is multiply into 4 and it will be 16, and you add together and you get 52. So 13 into 4. So we can say that this 33397 is divisible by 13. Next is 14. For that we apply the rules of after prime factorization, that is we can write 14 as 2 and 7, and these are obvious co-prime number must be. We have to check the number divisible by both 2 and 7. Let's take one example, 784. It is divisible by 2 because last digit is even number, and you apply the 7 divisibility rule, or you can simply divide this to get that this is also divisible by 7. So 784 is divisible by 14. Next is 15, and you can write 15 as 3 into 5. You can say that when the number is divisible by both 3 and 5, then it is divisible by 15. Let's take one example, 1440. This number is divisible by 5 because there is a 0, the unit digit number, and sum is 9, all digit sum, so it is divisible by 3. So this number is divisible by 15 also. For divisibility rule of 16, we have to check the last 4 digit divisible by 16 or not. Another method is we learned with example 39120. We have to check the 1000 digit number. If it is odd, then we consider the last 3 digit number and add 8, and we get 128. Now we have to check whether it is divisible by 16 or not. So it is divisible by 16. So we can say that this number is divisible by 16. But if it is even, let's take one example, that is 600896. Now again we consider the 1000 digit number 0 and it is even, and for this case we have to simply consider this 3 digit number and verify it whether it is divisible by 16 or not. So it is divisible. So you can say that this number is divisible by 16. Next we learn divisibility rule of 17. For this, let's take one example, 2754, and we can remember that we have already learned that the divisibility of 7 is actually we multiply the last digit with 2, but here we multiply with 5. So for 17 it is 5, for 7 it was 2, for 17 it is 5. So difference is actually 3. Why we consider this? Because there is a relation of divisibility rule in between 7, 17, 27, 37, 47, like that, so on. So after this we get 20 and deduct it to 5, and we get 5 and 2, and if we again multiply 5 and 25, it is 0. So 0 is divisible by 17, or it would be multiple of 17. Next is 18. So again we have to prime factorize it. You can write as 2 into 9, and you must remember also here also these are the co-prime number, and we have to check the divisible by 2 and 9, and you already know the rule. Next is 19. Let's take one example, 437, and for 7 we actually, the rule of 7, what we have done, we deduct it, but here we multiply 2, the last digit to be what, 14, and here we add. It is very important, here we are doing add. So it is 7 and 5. Okay, so 57, we know that 19 into 3, so it is divisible by 19. Next 20, the last two digits divisible by 20, or if it is 0 0, the last two digit. Next is divisibility rule of 21. Again we can prime factorize 3 into 7, and these are co-prime number, and you have to check whether the number is divisible by 3 and 7 both. Next, divisible by 22. Again you can write as 2 into 11. We have to check divisible by 2 and 11 both. Next is 23. For this, let's take one example, that is 3128. Then we have to multiply this last digit into 7. Okay, it will be 56, and we add the rest of the numbers. So it will be what, 8, 6 and 3, and again we multiply 7 and 56, we get 92, and 92 is divisible by 23. You can say that 3128 is divisible by 23. Next is 24. We can prime factorize with 3 and 8. So we have to check it, divisible by 3 and 8 both. Next is 25. We have to check last two digit divisible by 25, or if the last two digit are 0. For divisibility rule of 26, we have to prime factorize 13 into 2. So we have to check divisible by 2 and 13 both. For 27, we have to remember the rule of 7 and 17. Let's take one example. 6507. Again, remember, for 7 we multiply with 2 and deduct with the rest of the number, and for 17 we multiply 5, 3 gap, and here for 27 we multiply 8, 3 gap, 3 gap, 3 gap, multiply with 8 and deduct it. Is 56. So 594, and again we multiply with 8, 32, 27, and it is multiple of 27. So we can say that 6507 is divisible by 27. Next is 28. So we can say if the number is divisible by 4 and 7 both, because 4 into 7 is equal to 28, and they are the co-prime number. 29. For rule of 29, let's take one example. 5510. The rule is that you have to consider last 2 digits and you multiply with 9. So it will be 19. It will be 90, and we add 145, and it is, then we check whether it is divisible by 29 or not. So 5 into 29. So it is divisible by 29. Next is 30. For this, check divisible by 3 and 10 both, and 31. Let's take one example. 2976. To multiply the last digits with 3, 18, and deduct it. 2, and again multiply 3, it will be 27, it will be 0. So it is divisible by 31. So we can say that the given number 2976 divisible by 31. Here. Next is 32. For divisibility rule of 32, you have to check last 5 digits divisible by 32 or not. If it is divisible, then the entire number is divisible by 32. Then 35. So we have to check divisible by both 5 and 7 or not, because it is 5 into 7. So the number will be divisible by 5 and 7. Next is 36. For that we have to check the number is divisible by 4 and 9. Then 37. For this we apply the 7, 17, 27 continuation rule. Next is 37. What we have done here, for 7 we deduct the last digits, multiply by 2, and here it is 5 and here it is 8. So now it will be 11. Okay. Let's take one example. This 3552. What you have to do, multiply last digit to 11 and deduct it from the rest of the digits. So it will be 22, it will be 333, then multiply 11, we get 33 and 0, and we know that 0 is divisible by any number, so it is also divisible by 37. So we can say that the given number 3552 is divisible by 37. Next is 38. So for the divisibility rule of 38, we have to check the number is divisible by both 2 and 19, because 38 is equal to 19 into 2, and these two numbers are co-prime number also. Divisibility rule of 39, we have to check the number is divisible by both 3 and 13, because 39 is equal to 3 into 13. Or divisibility rule of 40, we have to check the number is divisible by both 8 and 5, because 40 is equal to 5 into 8, and also these two numbers are co-prime number. Every time we factorize it, we check whether the numbers are co-prime number or not. Clear? Thank you for watching this video.